Welcome to myprojectbazaar.com. Our product title is Modeling and Analysis of Class EF and Class E by F inverters with series tuned resonant networks. Next, we see about abstract. Resonance switching topologies are the next generation of power conversion circuits when compared to traditional pulse width modulation topologies. Resonance based supplies are most efficient than their PWM counterparts. This is due to the zero current and or zero voltage transistor switching that is inherent in a resonance supply designs. This features also provides an additional benefit of eliminating undesirable electromagnetic radiation normally associated with switching supplies. The switching devices in converters with a PWM control can be gated to synthesize the desired shape of the output voltage or current, but at high switching frequency the switches are subjected to a high voltage stress and the switching power loss also increases. This disadvantages can be eliminated by using resonant pulse inverter. In this operation at very high frequencies and to rabbit on and off control. This kind of features include low semiconductor voltage stress, small passive energy storage requirements, fast dynamic response, and good design flexibility, and so on. Generally, Class E resonant inverters are theoretically capable of delivering any power to a load and achieve 100% efficiency at any frequency of operation. In practice, efficiency in the high 90s can be achieved into MHz frequencies regardless of inverter output powers. Next, we see about flow diagram. Generally, we know that inverter is a process of converting DC to AC. Here the input source is DC source. That DC supply is fed to the choke. Choke is a passive element. The electronic devices we encounter all around us are driven and controlled by the flow of electrical current through electronic circuits. Each circuit is an arrangement of electrical elements designed to perform specific functions. Circuits can be engineered to carry out a wide variety of operations, from simple action to complex task, according to the jobs the system must perform. The first one of passive element is resistor. A resistor is a primary type of physical component that is used in electronic circuits. It has two leads. The material placed internally between the leads of a resistor that oppose the flow of current or flow of electrons. The next one is capacitor. It is another primary type of physical component and is used in electronic circuit. It also has two leads and is used to store and release electric charge. A capacitor ability to store charge is referred to as its capacitance. The capacitance is measured in farad. The next one is coil. Coil is also called as inductor and is another primary type of physical component that is used in electronic circuits. It has two leads and is typically implemented as one or more windings of conductive wire. That wire is often but not necessarily formed around a core of iron or steel or some other magnetic material. When the current flowing through the coil that induced a magnetic field that serves a store of energy. Generally, inductance is measured in henries. The choke is next connected to switch. Switch is nothing but power switching devices. Power electronic devices which act as a solid state switches. Some other power switching devices are power diode, MOSFET, PJT, IGBT, SCR, GTO, MCT, and so on. When the pulses is given to the switches, then only that switches are start to conduct, except power diode. The pulses is generated from the pulse generation circuit. Here lot of pulse generation techniques are used in normally. Here we using sinusoidal pulse width modulation technique. That pulses is fed to the that corresponding switching gates. Next, that switch is connected with tuned circuits element. Tuned circuit elements contains that passive elements, resistor, capacitors, inductors. Tuned circuits elements is nothing but that resistor, inductor, capacitor are specially connected. That is called single tuned circuit. Many communication applications used tuned circuit. These circuits are assembled from passive components in such a way that they only respond to a narrow band of frequencies. Applications include radio receivers, RF amplifiers, local oscillators, IF amplifiers, filters for frequency divisions, multiplexing, and so on. Next, that element is connected with load. Load is a resistive load are typically used to convert current into forms of energy such as beat. Unlike inductive load, resistive loads generate to magnetic fields. Common examples include most electrical beaters and traditional lighting loads or resist or resistive load. Next, we see about running process of our product. First of all, we open the MATLAB window and select the corresponding source code. This is our output current waveform for using E by F resonant in. This is our output current waveform for using E F resonant inverter. This is our output voltage waveform for using E by F resonant inverter. This is our output voltage waveform for using EF resonant inverter. And compared to the conventional method, our product overall efficiency is high and output power is high and also having high power capability.